Okay, we can start now. As I was saying, I wanted everyone to know that you are also part of the MV team, which is the most valued engineers team of the Huawei Enterprise Community. And I want to thank you for hosting this webinar. And now I will allow you to take over and start the presentation.
As Elena introduced, I am a member of MV team. My name is Tesfamariam Girma. And today's webinar, I'm gonna discuss about the basic principles of the Layer 3 Mpls. Here is my enterprise experience. I have been an IP and IT and enterprise wireless engineer in the telecom for about 3 years, and have taken these industrial certifications like HCI, routing and switching, WLAN, and HCIP, routing and switching. In addition, other vendor like Cisco, routing and switching, CCNA. I'm a member of this MVE team. In today's webinar, we're going to be discussing about Mpls basic principles, and then in the next session, we're going to be discussing about the configuration on the lab environment of eNSP, and then we'll have a live question and answer session that we will ask some questions and I'll try to answer them. And finally, there is a question and answer session on the forum, and I will be presenting you 3 questions. Okay, let's start about the basic principles. First, we have to tell about MPLS. That means, what is MPLS? It is a multi-protocol label switching. It is a layer 2.5 in the OSI layer, because it doesn't belong to the 7 layers of the OSI, but between the layer 3 and layer 2 MPLS, layer 2 OSI layers, that means the data link layer and the IP layer, that means it's layer 2.5. That is why it's called layer 2.5. And with the appearance of the MPLS layer 3 VPN, there are lots of advantage in the technology. That means the first one is it is scalable. When we say scalability, without redesigning the topology, that means the MPLS ISP topology of the network, we can just add the PE router on the edge of the MPLS network. That means next to the P router. That is what we mean by scalable. And the other one is its security. Even if Mpls doesn't provide encryption by itself, but it does provide a layer 3 VPN service. It enables the customer's data to be transported safely. That means the Mpls network, that means the ISP wouldn't see anything about the customer data. And the third advantage of the Mpls layer 3 VPN is it's fast, because it's the provider only checks the level, as I told you earlier, in the outside layer of the packet, which means no need for decapsulation of the customer information. It just passes the packet through the provider network. The other one is interface independent. Unlike other methods, MPLS is interface independent, which means one side of the customer edge, that means can be, for example, T1 line. The other side can be DSL or fiber line. This makes it independent. That means whatever link you can use, it doesn't matter in MPLS network. The other one is quality of service. When the data, which is, that means the type of service field and DCP field, are leaving the customer agent going towards the MPLS network, I mean to the provider network, they will be converted into experimental bits in the MPLS label and getting to the service provider, it will provide the quality of service by default. And the other one is the addressing space. As we know, there is this route distinguisher, which will enable us to use the IP address in different customers. That means the same IP address can be used for different customers with the help of the VPN instance. That means it will include the route distinguisher. And the last one in this webinar, that means there are lots of advantages other than this, but it's easy to create because of the virtual link between the distance links. That means this is an advantage of the layer 3 MPLS. And here is a topology, as you can see. There are these PE routers or provider edge routers. That means they are found in the edge of the provider network. And there is this is a P router. That means it's found in the provider, and the provider edge network is called also the label edge router because it's found on the edge of the provider network. And this is the IP network or the customer edge CE network. For the MPLS to pass the packets, they will use this path known as the LSP. It is the path that the labels are going through, and the distribution of the labels is done by the label distribution protocol LDP. They are manual LSP and dynamics, that means the LDP. And when the packet comes from this edge to this edge, this one is known as the ingress. That means the one that the packet is coming from is known as the ingress router. And this one is the egress. That means the packet is going out of the MPLS network through the egress device. That means here is how it works. As you can see, CE1 sends an IP packet, that means the VPN packet, and it will reach the data, that means the packet, to the ingress PE. And the PE1, for example, this is PE1. PE1 will check the packet, and it will check the packet from that is received from CE1 and search for its corresponding VPN instance on the VRF table. There will be a VRF table because VPN will be created here, VPN instance. And if it finds the match, the IPVPN packet is found, that means on the VRF table, it adds a label that, as you can see, it has this label and forwards to the next level switching router, that means the P router. The P router will see the packet and swaps the label. As you can see, OL1 will be swapped to OL2. Inner label will not be converted to anything, but outer layer 1 will be converted to outer label 2. This is called label switching, and it will be forwarded. It will pop OL1 and forwards to the next hop, that means the PE2, and the PE2 will only forward the data to the customer edge, which means it would use PHP or penultimate hop popping, because any MPLS label shouldn't be transferred to the customer, but only the data will be transferred to the customer. So this will be removed. That will make it working. And there is this Vrf instance. That means the Vrf instance means it's like a VPN membership of the customers. For example, if a customer is founded in the VPN instance and the other customer edge is found on the same VPN instance, that means they are the members of this VPN instance, and it's associated with one or more customer interfaces, as I told you, if they are the same. And this VPN instance is done on the VRF, on the provider edge device. We'll see it on the lab session. Okay. And there is this MPBGP. The MPBGP, that means the control plane. This is the control plane of the MPLS. And its main function is to customize the VPN customer routing information, as it's locally configured VRF information. To do this, it needs the route distinguisher, VPN label, and route target. We'll see each of them in this slide. What is route distinguisher? The route distinguisher, as you can see, is an 8th octet field that is added to the original IPv4 address. It is used to distinguish the route that is going to, and it's configured on the VPN instance, that means on the PE, and it makes the customer IPv4 address unique inside the service provider MPLS network. And there is this route target, and it's a BGP extended community attribute, but it is used to control the VPN routes because it's part of the MP BGP, which is a control plane of the MPLS. It has this export route target and import route target. By default, both are enabled. That means on both sides, export and import. So when we use this VPN target or route target, both will be enabled by default. For the route target, it's also used to update. That means only for updating the VRF table of the egress, and then in the direction of the network, that means the PE, the egress PE. Okay, the VPN level, it is used to forward the MPLS labels according to the ISP. That means, for example, if it starts from one side of the PE router, and it will forward like this. It's carried along the provider network. That means the VPN level. Because it is bound to the customer edge device, and this VPN is connected to the customer edge network. It's VPN, and it's forwarded in the label switching path as the direction of the incoming data. If it comes from this customer edge, it will be forwarded like this. And here is how the control plane is gonna work. There is this site CE or customer edge 1. It has this IP address. That means this is its private IP address, and its next stop is itself. That means CE1, and it will forward this data. That means this data to the provider edge network PE1, and provider edge network PE1 will receive the IPv4 from this CE1. It can receive this IPv4 address with eBGP or Ospf or either other ISIs and other routing protocols and forwarders to the next stop. And as you can see, it will create an MP-IBGP relationship with this one. This is IBGP. It's MP-IBGP between PE1 and PE2. And here it is eBGP, maybe. It can also be Ospf. This is MP-eBGP and this is MP-IBGP. MP-eBGP means it is on the VPN instance, and MP-IBGP is on the VPN v4 family, address family. So the PE1 will receive the IPv4 in eBGP, and it will convert the the received IPv4 address to VPN v4 address, and its constructs, as you can see, MP-IBGP update message with route distinguisher of 10110, and its next stop itself, and the route target is this one with a level of 100. And what it does is that it will associate the route target values, which means export 201 per VRF, and it will rewrite the next stop to itself, and then it will assign a label, as you can see, label 100, and install it on the Mpls forwarding table, and it will be seen on the Mpls forwarding table. Then it will send the MP-IBGP update to the other PE or PE2 router, that means, and that way PE2 will receive the packet and will check this one, the route target 201, and if it is locally configured in the VPN, which means the VPN will be configured in here and in here. As you can see, it's already written here, VPN1, VPN1. They will be configured in this and in this provider edge device. If they are the same, which means if this is configured on the VPN1 of PE2, it will import the route target. That means 201 within any VRF, and it will update the VRF table, and it will finally advertise the IPv4 prefix to the customer CE2 using a routing protocol, whatever it is. And here is how we configure the Mpls and LDP. Here is the configuration steps. In order to configure the MPLS, first we have to define the label switching router ID globally, and we will have to enable the MPLS again globally. And after MPLS process is started, we will have to define the MPLS distribution protocol, that means LDP, which is the dynamic one. And on the interface that is connecting to the MPLS network, we will enable the MPLS. And again, it's label distribution protocol, which is the dynamic one, LDP, not the static one. There is also static LDP distribution protocol, which is not preferable in nowadays, because there are many MPLS labels. It will be time taking. And then we will configure the VRF, as you can see. For example, in our example, the Vrf instance or the Vpn instance name is test, and the route distinguisher is 101. And its VPN target or the route target is also 101 pose. When we say pose, it means both export and import, which means when it is egress, when PE1 is egress, it will act like an export community. When PE1 is acting like an ingress router, it will act like it will be import community. That is why we configure both. And after we do this, we will attach this VPN instance to the router, to the interface that is connecting to the customer edge. And as you can see, it's binded in the interface. When we do this, the configuration, all the configurations will be removed. So we have to reconfigure again like this. And we have finished configuring the VPN instance. So after that, as I told you earlier, we will configure BGP on the MPLS network. That means on PE1, we'll configure its router ID and its peer. This is called IBGP with its loopback interface, and we will convert this one into VPN v4 by this command. This command is used to convert the normal IPv4 peering to VPN v4 address, that means. And after that, we will finish configuring IBGP. This is done on both PEs. We will see it on the configuration. And after that, we will configure MP-IBGP. MP-IBGP means between the customer edge, and EBGP means, sorry, between the customer edge and the provider edge. That means on the VPN instance family, because it belongs to this VPN. This is how we include it on the Vrf instance of the BGP. This is the AS of the customer edge, and the same will be done here. On the customer edge, normal BGP peering, that means BGP, eBGP peering will be done like this. And we will also, I forgot here, but we will advertise our internal network, like with this command, network 11.11.11. That means this is the internal network. we will advertise it to the PE with this command, and then we will see the VPN instance. That means on the PE1 using display IP routing table VPN instance test, and we'll see the routing. That means the one that is advertised using the next stop or the VPN. And after that, we are gonna see on the lab. Let me change this to the lab. Okay, until it starts, you can see here is our laptop. Here is a Mpls or provider edge network, and here is the customer edge devices, which are found on two different autonomous systems. And here is okay. As I told you, here is our topology. This is the one that connects to the customer edge, and this one is the interface that connects to the P router, and this is its local address. The same as this one is that connects to the PE1, and this interface connects to the PE2, and sorry. This is the one that connects to the customer edge CE2. Okay, and this is a customer age 2, that means display IP interface brief. So all is configured, pre-configured here. This is the interface that connects to the PE2. So let's start to configure the MPLS network. In order to do that, first we have to connect this and this one using IPGP. That means maybe OSPF or ISIS will do it. So in order to do that, we choose OSPF. So and we will configure OSPF relationship between PE1 and P router and the PE2. This means we will advertise this network. And we will advertise also the loopback address like this. We will not advertise this network to the ISP or MPLS. So we will leave it because it's connecting to the customer edge. The same is going to be done on the P router. So we advertised this network and the one that connects to the PE2 to the OSPF. And lastly, okay, unfortunately here, no loopback address is introduced, so we will introduce interface loopback 0 IP address 3.3.3.3.2, and we will also configure OSPF relationship like this, OSPF1 router and now we will have to check if this router and this router are connected by pinging ping 23.1.1.2, which is pinging because OSPF is already done. So after that, we will configure the MPLS. So first, as I told you, MPLS LSR ID will be defined on all the MPLS network device. The LSR ID is the same as OSPF router ID or the loopback IP address, and we will enable MPLS globally. It is already started. We'll configure its distribution protocol, which is the dynamic one globally. We already finished that. And on the interface that connects to the P router, that means G0001, we'll configure MPLS, and it's already label distribution protocol. And we already finished MPLS configuration on PE router. On the PE router, on the P router, we'll also configure MPLS LSR ID, the same as the PE router. Interface G001, which is connected to the PE1, and we'll configure MPLS. Mpls. Because we didn't configure the Mpls LDP globally. So interface G001 Mpls LDP. So we configured the label distribution protocol for G001. Same is going to be done on this interface that connects to the PE2. So we finished configuring the Mpls on P. The last one is Mpls LSR ID, and we'll configure the distribution protocol globally and in the interface that connects to the P router. We will enable and configure its distribution protocol, which is a dynamic LDP. Now we have done this. We can see display Mpls LSP, which is this one. Now already Mpls LFIB is created on all the Mpls devices. You can also this along with the in or out label. Now we configure this on all the provider is router. We have to proceed on creating the VPN instance like this, IP VPN instance. The name maybe as it is, let's call it test. And we'll configure a route distinguisher 101. This is to distinguish where it is going, and we will configure the route target using the VPN target command. Both. So we will do in both export community and import community. And after we finished creating the VPN instance, we will bind this interface. We'll bind this VPN to the interface that is connecting to the customer edge. That means G00 display IP interface brief and IP binding Vpn instance test. We are doing now the binding. When we do this IP address will be removed. All IP information will be removed. So we have to configure again. So all we have to do is configure the IP address again, like this. So we have done the IP binding, and the same VPN instance will be created on the PE2 router. That means IP VPN instance test our distinguisher VPN target. Sorry. So we'll bind the IP address with this interface. That means G001 interface G001 IP address IP binding VPN instance test. And we'll configure the IP address again 20.100.230. Then after we configure the binding, the final step is configuring the MP IBGP between this PE1 and PE2. So let's do this. The BGP 100, the AS is 100 for the provider is network. So we'll do the peering like this. Is 100. This one is the loopback address of the PE2, and we'll connect using the loopback 0 interface. And as I illustrated in the slide, we'll convert this into this VPN v4. That means PS3 enable. Sorry. So we converted to the VPN v4 address family. And again, we'll do the IBGP with the CE1. That means 10.1.1.1. This will be done on the VPN instance test because it's part of the VPN instance. We'll do it on this here 10.1.1.1 S65000. On CE1, we'll define this AS number and we'll do the peering with the 10.1.1.2, which is found on the AS100. And we will advertise our network. That means the internal network. The loopback address is represents the internal network. So this one will not do anything, but only acts as a label switching router, as a core labeling switching router. Peering, that means IBGP with the PE1 to be done. And we will convert it on the to the VPN v4 family address family with this command. Oh, sorry. And also we'll do the peering of the BGP with this one, which is found on the BGP 65001. And the same is going to be done here. (65001) here 20.1.1.2 is 100, and we will advertise our internal network 22.22.22.22, which means the loopback 0. So we have now done the peering. We'll see the display BGP peer. Let's verify. So IBGP peering is established between PE1 and PE2, and display BGP and Vpn instance test peer. So peering is established between the VPN instance CE1 and PE1. Also, peering between PE1 and PE2 is done, and display BGP peer also done. So the final part is checking if the internal networks, that means 11.11.11.11 from CE1, is found on the networking table of the IP routing table of the CE2. Display IP routing table. So As you can see, using the eBGP already configured here. So now we can check also in this one. Sorry. So the internal network of the internal IP address of the CE2 is found on the CE1. That means the MPLS tunnel is working. We can do like display MPLS LSP. As you can see, the forwarding equivalent class carried the internal IP address of the CE1 on the VPN, and here is its outer table. The inner label and the outer label is nil, and it's found on the VRF test. This will be done on each and every different MPLS VPN instances. You can also check the LSP here. So as you can see, here is the FVC, here is the direction, and we can now check pinging from this one, from CE1 to CE2. First, let's check to ping directly with interface G000. Sorry. As you can see, it's not pinging from the G000 interface because G000 is connected to the PE network directly. So it will have to connect with source of 11, 11, 11, 11. 20, 20, 20, 20. Now it's working because the ping packet is started from internal network, and it will go through the internal network, and we can also trace how it goes. Here is why we say MPLS is secure. As you can see, it touches directly 10112 interface. That means this interface, and it doesn't cross any of this router IP address. That means 12.110 or 23.110 network. It directly jumps to the 20.110 and next up of 21.1.1. This makes it secure, and as you can see, it's fast. Here is why we choose the MPLS method. So here is how it's gonna be done. This is a simple one. That means MPLS intra AS MPLS. That means the AS is within the same AS. That means the MPLS. There are inter AS MPLS option A, option B, and option C, which are widely used in the world when there are one or more IP service providers in your country. So this is how it's gonna be done. I have finished. Let's get back to storage. If you have any question, you can ask.
Okay, thank you for your presentation. I see we have multiple questions. Daniel was the first to ask, please.
Hi, Mariam.
Okay.
Can you hear me?
Yeah. Hello.
Hello. I have a question about loop avoidance mechanism in BGP. When you establish eBGP peer relationship, then why you haven't modified loop avoidance mechanism for eBGP membership?
The eBGP relationship, that means which is created between the
CE1 and
PE1 and
CE2.
CE1. PE1 and PE2, I didn't do eBGP. I just done IBGP, as you can see.
No, between
Mhm.
C1 and C2, you advertise routes between C1 and C2, but their autonomous system number is same. As I have
Uh,
learned, there is a loop avoidance mechanism.
the autonomous number is, as you can see, it's 65000 for
Yes.
CE1 and 65001 for CE2. You see, they
Okay,
are
got it.
different.
Okay.
Yeah.
What about when they are same? Like when we have service provider where same autonomous system for both sides. We have to
When we can establish, but the concept of this one is to establish MPLS network. It can be established between CE1 and CE2. That
I,
means within, yeah.
yes,
But
when we have same autonomous system, we can create, but we have to just modify its loop avoidance mechanism for BGP. I think
yeah,
so. If am I right?
yes, yes, and also you see, as you can see, it's connected to the PE2 and PE1 router
Okay.
for different P customer edge devices. So you see, it's on this family. This means on the VPN instance family, the peering is done on the VPN instance family, not directly to the BGP. BGP.
Yes, but when we have a service provider, we have to connect to same autonomous system offices through Mpls or IBGP network, Tor network. Then
Yeah.
for that, then you please consider that part.
Sorry. I didn't.
I say if you change autonomous system of C2 to 65000,
Oh, you mean 65000?
yes, on both sides, on
Oh,
C1 and C2.
yeah, the same. I haven't tried that, but the same configuration is gonna be applied. That means there it is gonna be. Let me do it. Let me
Yes.
do it like that. First, okay. For example, we can change this one. Uh, you mean like this?
Yes, yes.
Okay. This only is gonna be changed like this. Nothing else is gonna be changed. Only the AS number on the PE router and the CE router, and we will display BGP peer. Oh, it's connecting. it will be established and as you can see, it will not advertise with the routing table of the CE2 because they are in the same. We have to configure directly, as you said, IBGP relation with CE1 and CE2.
Yes.
Yeah,
And
yeah. Sorry, my battery is almost finishing. So I will post this in the forum, okay?
okay. Yeah.
Okay. We can continue to the next question.
Okay. Thank you so much.
Okay, no problem.
Hello.
Yes.
Hello, sir.
Yeah.
Sir, I just want to know, could you please explain the significance of VRF while configuring MPLS? Is this always mandatory to configure VRF? Because as we studied in CCNA, there you just write MPLS IP command and the MPLS gets started. But here when you were showing us PPT, you were explaining the concepts of VRF. Then I searched it also that they said that, okay, VRF is good. But VRF is mandatory while configuring MPLS, or it can be skipped.
VRF, the main significance of VRF, as I tried to show it on this one. When we configure VRF on the PE routers, that means on the provider edge router, we just configure the one that will identify the route distinguisher and the route target, and it will also enable us to use the same IP. For example, VRF1 and VRF2 can use the same IP, but they are in different VRF, and their route distinguisher is also different, which will which will be used as an advantage of addressing space. This is addressing space. That means the addressing space advantage is guaranteed due to the VRF. That is the main purpose of the VRF. That means the same IP address can be used on different VRFs. That is the advantage. Okay.
Okay, so suppose if I don't want to use same IP address, then in that case, VRF is not required.
Yeah, yes. That way you can use another forwarding method rather than Mpls. That means.
Okay, thank you, sir.
Yeah. Okay, no problem. Okay. Okay, who is the next question?
Hello everyone. So first
Good
of all,
morning.
thanks for the presentation. It's very helpful. Actually, I have two questions. So, what is the recommended routing protocol between the customer and the PE
Sorry,
router?
please keep your volume up.
Yeah, sorry. So I said, what is the recommended routing protocol between CE customer and the PE router?
Okay. I recommend to use the eBGP rather than the Ospf, but most of the time eBGP is used when MPLS is configured in the enterprise network. So I recommend eBGP. Okay, what is the next question?
And what is the function of the VPN label?
The VPN label? The label?
Yeah, the VPN label, yes.
So the VPN label will be used, where is it? So the VPN label is used to carry the route distinguisher throughout the MPLS network. This one, you see, this is the label, the VPN label. It will carry out the route through the MPLS network between the two PE routers, as you can see. That is the main purpose.
Okay, thank you very much.
Okay.
Hello.
Hello.
Yes. Hi.
Okay. Hello. Hello.
Yeah, it's me, Ali Abdurrahman. So
Okay.
actually, and first, regarding Daniel, secondary question was asking regarding if we configure the same AS number on both CEs, so that
Yes.
the routes will be like advertised and received on each CE. Because I came through the same scenario actually. So in this case,
Okay.
normally the AS attribute, it will be like modified from the service provider side. I mean from the BE
Okay.
side.
Okay.
Because if we use the same AS, then the loop prevention mechanism will work, and whatever advertisement coming from this AS will be discarded on the other end MS.
Okay.
So yeah, for me now, my question is regarding the P, like
Yes.
to establish this configuration between PE1 and PE2 on the
Yes.
B side, which is the backbone of the network. So do we configure like normally any BGP here? As I know so far, we are configuring the BGP, the MBGP between the BE1 and PE2, right?
Yeah. Yeah.
But like for the B side, we only configure the IGP. I mean, like whether it's like OSPF or ISIS or something like that.
Yeah.
We need to
Yes.
configure IGP on the P.
Yes. Because it's not acting like.
Actually, your voice was not clear, Habib.
How about now?
Yeah, it's okay now.
Okay. So the PE router is used to forward the label switch. It's a core label switching router. That means core LSR. Its main purpose is to forward the labels that came from PE1 to PE2. Its main purpose is no BGP relationship is going to be configured. Just the IGP is configured to establish the relationship between PE1 and PE2. That is its only main purpose. Yeah.
And also to establish the MPLS, right?
Yes. Yes.
Okay. Okay. One more question, brother. Regarding
Okay.
the label, like for
Yes.
example, on your network here, we have 11.11.11.11 on
Yes.
CE1. So when we are distributing the labels from the PE1 perspective, so the inner label, like for example, as I was seeing, it was 1026, right?
Yes.
And the out label was null.
Yes. Yes.
So like, can you explain this, like how like they will distribute it? I mean, like it's in dynamic way, as I know so far.
Yeah.
But
Yeah.
is there any mechanism, any criteria that we can know? Like for example, if I have more other networks, they will have the same in label, out label, or it will be like different, yeah.
Yeah. In Huawei, I do not know how to configure the label with different. In Cisco, it can be configured as different labels. You can configure it the MPLS label differently, but it will remove the out label when it reaches the PE2. That means one hop.
You mean the static? You mean the static label distribution?
Yeah, yeah. No, that static it can be configured. I mean, it can use PHP or penultimate hopping mechanism when it reaches this one. That is why, as you can see, MPLS LSP. It will remove this one. You see, that's why it becomes null.
So now, for example, now you are checking on PE2, right?
Yeah.
So actually this network 22, yeah, can you just stay on P2, please?
Oh, P2, okay, okay.
So now for this network 22.22.22, the in label is 1027, right? So that means for the network when it hit to the BE side, right?
Yeah.
So when the PE2, it's advertising this network to another PE or like to the B, and then the B will deliver it to BE1, then he will use the out label is null, right?
Yes, yes.
So in this case, for this network 22.22.22, on B side, we need to see that the in label should be null, right?
Yeah. No, no, not the in label. That means the one that comes from this FPC, the one that comes from PE1. As you can see, the in label is null, not the, because this one is in the direction of the PE1. You see, that's why.
Okay, man. Thank you, man. Great job. Thank you. Thank you.
Okay.
Thank you.
Thank you. So for the others, can you ask me the questions with the forum, because my battery is going down and the power is there is no power in our area. So you can ask me in the forum. Let me continue to the next. Okay.
Hello.
Yes, yes.
How much time can you still be online? Because if you don't have more time, we can move the questions to the forum directly.
Okay, okay.
How do you prefer?
Yeah, we can move the questions to the forum because I have only 9% battery left in my laptop.
Okay, then everyone who still has questions can please go to the Huawei Enterprise Community. You can find the webinar post there, and you can ask your questions under the forum post. And also you will find 3 questions and you can reply them in order to have a chance to win a $20 Amazon.com gift card. If you can go to that slide with the webinar post in the presentation.
So I will attach the questions in the webinar.
Yes, I will update the forum post and add your questions there. Because if you can be online for much longer, I don't want there to be any issues. So.
Okay.
But if you can go to the presentation and show the slide with the forum post, because I want everyone to see how they can find it.
I can see it now.
No, I think you're in eNSP now.
Okay, let me share that screen.
Yes, the next one. Yeah, we can see your presentation. Okay, guys, this is the community post. You can see the link there. It's forum.huawei.com, Enterprise English Community. You can find the webinar by the name. You can leave your questions there, and Tesfama will be able to answer after this live meeting. And you will also be able to find the 3 questions that you can answer for a chance to win. We will choose 10 users who will be announced in a few days after the webinar. And thank you for your time. Thank you for your presentation. I'm sorry we've had some issues, but we are adjusting to this new situation with remote work, and let's hope everything will be okay soon. Thank you, everyone. We're sorry. if you think you have more time to take one more question, we will take one more question. If not, we will go to the forum instead.
Okay.
So
maybe
it's
I
up
can
to you.
join. Maybe I can join the webinar with my mobile. If there is any question.
No, if you're not sure, you can you have enough time to answer. We can just go to the forum, and so everyone can go to the forum post and leave their questions there, and Tesfama will reply soon.
Okay, that is preferable.
Yes, yes. If it's better this way, we will do it this way.
Okay.
Okay. Thank you everyone for watching. We will have more live webinars very soon. And as I said, you can go to the forum, you can search the webinar post. As you can see, the title is just like the title of this meeting. And you can both leave your questions and leave your answers in order to win. So this was it for today. Thank you everyone for being here with us. And stay tuned for more live webinars. And thank you, Tesfama, for your time.
Okay, thank you.
Thank you.